For our fourth lesson in the congruent triangles unit, we're going to look at some special properties of isosceles, equilateral, and right triangles. There's some specific vocabulary involved and a couple of theorems. Right triangles are so important, we're actually going to do an entire unit on right triangles later. We're just going to kind of hit the tip of the iceberg, so to speak, in this unit. So what do I need to know about isosceles, equilateral, and right triangles? Alrighty, to begin with, let's talk about isosceles triangles. So here we have triangle ABC. It is isosceles. I can tell by the two tick marks on AB and BC. The two congruent sides in an isosceles triangle are called legs. The angle where the legs intersect is called the apex angle. Sometimes you see it called the vertex angle. Okay, so that would be angle B here where the two legs intersect. This is the apex angle, sometimes called the vertex angle. I'd actually never seen it called the vertex angle before your textbook. I mean, all three of those angles are vertices of the triangle, so to me that's kind of a weird name for it. I was always taught apex angle, but I have seen both words show up on the SOL recently, so you do need to know both. The side opposite the vertex angle, so the side that is not congruent, that's called the base. Not congruent. Okay, and the angles along the base are called base angles. Very creatively named. The interesting thing about base angles is base angles are congruent. We have a theorem that's going to talk about that in just a minute. So, base angles, base, apex angle / vertex angle, and legs are all vocabulary words you need to make note cards for. Let's look at a theorem here, very creatively called the base angles theorem. If two sides of a triangle are congruent, so in this case, if AB is congruent to side BC, then the base angles are congruent. Then angle 2 is congruent to angle 3. Okay, it's not the angle between the apex angle, but the two angles at the bottom or base of the congruent sides. This works in reverse. And when you take a conditional statement and switch it, it's called the, you remembered, converse. Ooh, Unit 2. Inverse, converse, biconditional. I bet I even worked biconditional into this lesson. If two angles of a triangle are congruent, so in this case, if angle 2 is congruent to angle 3, then the sides opposite. So if I go opposite angle 2, here I am at BC. And if I go opposite angle 3, here I am at AB. So if you have two congruent sides, you have two congruent angles in a triangle. If you have two congruent angles, then you have two congruent sides in a triangle. Base angles are very interesting. Let's talk about equilateral triangles. A triangle is equilateral if and only if it is equiangular. Told you I could work in biconditional. Right? So, if the measure of angle A equals the measure of angle B equals the measure of angle C, no picture. I need one. I do not want to see you trying to solve angle problems without diagrams. The measure of angle A equals the measure of angle B equals the measure of angle C. Then, segment AB, the length of AB, excuse me. Didn't want highlighter. Equals the length of BC equals the length of AC. Or, because we're just wrote the conditional, now we're going to write the converse, which gives us the biconditional. If the length of AB equals the length of BC equals the length of AC, then the measure of angle A equals the measure of angle B equals the measure of angle C. If all three add up to 180 degrees and they're all the same, 180 divided by 3 is 60. Equilateral triangles are equiangular and all three angles equal 60 degrees. How about right triangles? A right triangle has two acute angles, and those two acute angles have an angle pair relationship. We talked about it in lesson 1. The angle pair relationship between the acute angles is that they're complementary. The longest side is opposite the right angle and called the hypotenuse. Another word you should practice how to spell. So if I come opposite the right angle, this is my hypotenuse. I spell it hypotenuse, but it is pronounced hypotenuse. The two sides that make up the right angle, this one and this one, are called legs. Notice we're using the same word to describe something different. In an isosceles triangle, legs are congruent. In a right triangle, that's not always true. And of course, let's not forget our friend Pythagorean theorem, a squared plus b squared equals c squared. So a couple of more vocabulary words here. Pythagorean theorem, legs specific to a right triangle, and hypotenuse. Okay, let's try a couple of these. Let's see, what kind of triangle do I have in number 1? I'm noticing that I have an isosceles triangle. So that means these two angles are base angles and they are congruent. 9x minus 33 equals 4x plus 7. All right, in number 2, I have two angles that are congruent. And that means the sides opposite them are congruent, right? This is base angles converse. Whereas number 1 was base angles theorem. All right, so if these two sides in number 2 are congruent, I can set them equal to each other. And solve my equation. Number 3, in triangle RST. Well, they didn't give me triangle RST, so I better draw it. And if you're not drawing the triangles when you're given a word problem, I am not going to give you credit on a test or a quiz. Now, I've deliberately made mine look isosceles because right here they're telling me I have an isosceles triangle. T is what's in both of these statements, so I'm putting it up here as my apex. RST. Okay, the measure of angle R is 9x plus 2. The measure of angle S is 13x minus 18, and these two angles are congruent. The measure of angle T is 17x plus 1. So 13x minus 18 equals 9x plus 2. These are my base angles, and base angles are congruent. Solve your equation. X equals 5. How am I going to figure out the angle measures? Well, I'm going to substitute angle 5 into each one of these expressions in order to come up with the angle measure. So let's see. 9 times 5 plus 2 is 45, 47. That's angle R. And angle S has the same measurement. I just didn't want to do 13 times 5. 17 times 5 plus 1 is 86 degrees. Don't forget your degree signs. At half a point per problem on the test, it's really painful when you forget that. Okay, for number 4, I have some formatting issues. I didn't mean for part of the problem to end up on different pages. If triangle PQR is an equilateral triangle, so let's go to the next page. Where's my diagram? Whoa, we're talking serious formatting issues. So PQR is equilateral. All 3 of these are the same. Okay, I also know equilateral are equiangular, and each of these angles is 60. Oh, so X is the simplest one to do. 7x minus 3 equals 60. X is 9. Okay, to figure out y, I can set any 2 of these sides equal to each other. 14y minus 59, that's looking a little big for me. I think I'll do the 11y minus 23 equals 9y plus 1. Those numbers are smaller, and I like smaller numbers. So 2y equals 24, and y equals 12. You could have used the 14y minus 59 equals 9y plus 1, or 14y minus 59 equals 11y minus 23, but why deal with numbers that big if you don't have to? Alrighty, so take a moment and write a summary of this lesson. Make sure you include key vocabulary for isosceles and right triangles, and make sure you talk about the theorems, base angles theorem and base angles converse.